Alright. Good afternoon, guys. My name is Maple. Welcome to Orchard Park Secondary School, home of FRC Team 2056. If you have any questions throughout the day, feel free to ask me. I'd like to introduce our speaker, Stephan, presenting Charging Innovation for Electrical Wiring.
Thank you. Yeah, so Charging Innovation is the title of the presentation. So a quick agenda of what I'm going to be going through. We're going to start with an about me. We're going to talk about electrical design, connectors, your batteries, and I'm going to have examples from our team and things that we've experienced scattered throughout, and a bit about how each section that I'm talking about has helped us. I do ask that you keep all your questions until you're prompted to. So a little bit about me. This is my 4th year on 2056. I've been electrical lead and business lead for 3 years. I've co-led our manufacturing team for the last 3 years as well, and I've been our technician for the last 2 years. So some basic terms for anybody that is a bit new to electrical. So CAN bus, it's the system that we use to communicate within all the devices on our robot. Torque is a force of rotation. It's measured in Newton meters, so if you ever hear me refer to that. And voltage is an amount of energy. It's very simplified, but you'll get the gist of it. Starting off with amazing electrical design there. Simplicity, do less better. Tyler Holtzman said it best. It's what our team's main philosophy is: do everything as simple and effectively as possible. The best way to start off with that is keeping all of your wiring simple, right? You don't want your wires to be too short, too long ever in your robot. Extra long wires are going to get bunched up, cause a lot of unnecessary buildup in certain areas, and occupy a lot of space. Wires that are too short are going to stretch really hard and put a lot of pressure on not only the wire, but the devices that they're hooked up to and other sections in your robot. And also keeping your wires organized. I always recommend keeping all your wires bundled together as much as possible and almost creating a highway of your wires and only branching off to exactly where they need to go. Making sure you're using simple devices. It's a philosophy on our team, obviously, to keep everything simple. And we take that even to the devices we purchase. For example, we use limelights on our team because we found that it's the simplest, most effective way to do vision tracking versus Photon and QuestNav. QuestNav has shown to be very interesting. It does very pricey and have seen it be very finicky. Obviously, the teams that have really pioneered it have gone really far with it, but I feel that the development curve required and the knowledge required to develop one of those systems is a bit too much for even our own team. Photon Vision is a great alternative and significantly less expensive alternative to Limelights. However, the added complexity of having to do a lot of that yourself can hinder some of the performance you get out of it. Keeping your circuits simple is very important as well in your robot. Complexity in your circuits adds more failure points and more areas where things can go wrong in your robot. For example, comparing a branched and looped CAN bus, branched CAN buses are very limited in what they can do. For example, you can only have about a 12-foot branch off of each loop, and you're limited on how many devices you can hook up to that. Whereas a looped CAN bus is very simple, and you can trace it very easily, making problems easier to diagnose. Additionally, the big downside, to looped CAN buses is that if you do lose one device, you can lose your entire CAN bus system. For some teams that use a lot of small CAN devices, that can be an absolute killer. Whereas on our team, we tend to use DIO ports for everything that doesn't have to be on the CAN bus. So if one of our CAN devices did fail, it would result in our entire robot failing anyway. Something that has allowed this simple philosophy has allowed us to do is find roots to problems much easier in a robot. If we look over here at 2024, great low key, we had a really interesting problem where on our home field, whenever we climbed, we died every time. Could not figure out why, but as soon as this climber touched the chain, we would die. We went through a lot of effort to find out how our robot was somehow grounded. I'll be honest, we didn't really find a solution, but because all our wire runs are so simple, we managed to rule out most causes very quickly. And we put some ferrite chokes on it and it managed to work. So we're really happy about that. But it was a very, very interesting issue that we had. But yeah, like I said, that simple philosophy let us rule out things like grounding to our chassis, wires being shorted, etc. Going on to motors. The most important thing that you can do with your motors is gear ratios. Making sure that you're gearing your motors properly for your application. I've seen a lot of instances where motors are geared too fast and have too much torque applied to them for their desired use. This puts a lot of stress on the motor and the battery. Um, it's probably one of the things that causes brownouts, consistent brownouts and matches the most. Um, if you always make sure that you have a bit more torque than you need, you're going to see better results and less jamming in your robots and seeing your mechanism stall. Um, a little bit on comparing some motors and motor companies. So between Rev, Talon motors, and brushed motors, like I said, Rev and Talon are both brushless motors. Um, Honestly, there isn't much of a difference between Rev and Talons. They have a little bit of pros and cons. The Kraken X60 does have a little bit more torque, but it's not a lot. And the Rev Neo Vortex does spin a little bit faster. Uh, they do have a large advantage over their brushed counterparts. Um, they do have about the same figures. The biggest downside is the weight penalty. It is atrocious. I think a sim weighs something like 2 pounds. I didn't write that down, but I should have. Whereas one of the Kraken X60s or Neo Vortexes can weigh between 1.7, 1.2 pounds. So that weight that you're taking off your robot is amazing, especially on mechanisms that you have high up on your robot where they don't have as much structural support. Uh, Built-in motor controllers. Is the cost worth the simplicity for them? In my opinion, it is absolutely worth it. You get less devices on your robot, which means that there's less individual wires you're having to trace that do different things. Um, I will admit that the cost between them is a little bit significant. It can be about 20 US dollars per motor, comparing Neo Vortexes to Kraken X60s and X44s. So that can be a bit pricey. Additionally, Rev does offer a lot of sponsorships to teams, and that can go a long way in what you're using as your motors. So there isn't a huge difference. Um, but I would say that if you have the option using Kraken X6, the Kraken ecosystem and their built-in motor controllers are a lot nicer. An interesting issue. I just have this because of motors. On our 2025 competition bot, we have our climber. Um, we were ratcheting our climber back up, and we had this really weird issue where our motor would suddenly release its brake, and we couldn't power it anymore. It's a really weird issue. I just wanted to share it with you guys. Turns out that if you back drive a motor while it's trying to brake, eventually it just gives up and won't do anything. Um, so in case you ever have a mechanism where you happen to be applying a lot of force in the other direction and it is enough, you might lose your entire mechanism. So just keep that in mind when you're designing your robots. Designing for your wires. Being able to access your wires is one of the easiest ways to solve problems in your robot. If all of your wires are in square tubing that has no lightning holes in it, you're going to get screwed over if something happens in your robot. Like I said, it can also diagnose the problems a lot faster as you can see inside of you see all the wires and you can see if something's happened to them. Hidden wires are very hard to know if something is specifically going wrong in that location without doing a lot of testing beforehand. Um, my second point there is reducing your crimp and cut points in your robot. It's one of the biggest things that can happen. It's happened to us many times. Um, Trying your best to avoid the tight bends and edges. In fact, there's actually a rule in the FRC rulebook, R202, that says no exposed sharp edges. I personally argue that unexposed sharp edges are even worse. The reason they say that is because they want to keep their staff safe. The reason I say that unexposed edges are worse is because you want to keep your students safe and you want to keep your wires safe. The sharp edges you don't see are going to be the ones that damage your wires and are the ones that students can get cut on very easily because they don't know they're there. And just because a wire bends doesn't mean it really should. Ethernet cables are a great example of this. They are very, very thin wires on the inside, and there's multiple of them. So they bend a lot more than those wires should be bending, which can very often cause small rips in the cables and just complete shearing. Um, Securing everything in your robot, making sure that you're using way too many zip ties if you can. It is our team's biggest addiction is basically eating zip ties. You can see everywhere on our 2025 and 2024 bot, we have way too many of them, but we're just trying to make sure that our wires basically can't move. If they move, they can get caught in things, and that is not good. Making sure that you're keeping all of your wires covered is really important, especially when they're in open air. For example, 2025, you can see we have our nice cable chain here. This is just to help keep all of our wires protected as they're going up and down as our elevator goes up and down. It's one of the easiest places that you can get snagged on another robot. And as much as it is a penalty to be interfering inside a robot's frame perimeter, it doesn't do much if your robot gets killed doing it. And trying your best to keep your wires away from moving parts. There are always times where things do get a little bit sketchy. Our 2025 bot has wires that run right next to belts. I hate it, but we don't really have an option for getting wires to certain places. But it is one of the easiest places that your wires can get severely damaged. On our 2024 bot, we had a wire that went to our limelight that was unprotected, and happened to be right behind our intake, and it ended up getting shredded. It was not great. So it's just trying to avoid situations like that. Oh, well, skipped ahead to my other point. Does anyone have any questions for me yet? No? Okay. Moving on to our connector slide. We're gonna go through some pros and cons of each connector. We get to a certain point, explain some stuff about them. So starting off with Anderson power poles. The biggest pro to them is that they're widely used, not only in FRC, but also outside of FRC. You can basically get these anywhere, which is great. They also have a nice locking pin that is amazing. It's a nice little plastic one. Holds your wires together. I always recommend you use it because your wires can come apart if you don't. And it is easily removable if you're ever having to replace a whole mechanism. Your wires just come apart nice and easily. The cons, they're also easily removable, especially if you don't have that locking pin in. Pulling them apart very quickly, results in that entire mechanism not working. The connectors do loosen up over time. The actual contacts, I've seen it many times on our team, where older motors that have the Andersons, the contacts loosen up and they aren't making great connections anymore, and it comes apart easier. They're very thick. They occupy a lot of space in your robot. In our 2024 practice bot, the conduit there was literally bulging because we had Andersons in there. Whereas on our competition bot, it's nice and secured. You just do have to keep that in mind if you are using Andersons, is that extra size penalty. Also being concerned with any weight that you're putting on your Andersons. That plastic locking pin can bend if there is enough force applied to it constantly, which can result in your Anderson popping apart. Wagos. There's the lever nuts specifically. They're really easy to use. Really intuitive. You lift it up, put your wire in, close the lock again. They're great. They're especially great for making changes. If you're looking at your practice spots, making sure that you can adjust your wires however you'd like is absolutely great. The cons to them are effectively similar to Anderson's, but a bit exacerbated. They have a really weak connection. I've seen wires slip out of Wagos too many times when we've used them because we do like using them on our practice spots. And it is very, very unfortunate if that happens on a competition bot. There's no locking mechanism for the lever, which means that if your robot gets hit the wrong way, sometimes that lever can just come out and your wire comes out, which again results in, especially CAN buses, because that's what we use them mainly for, just completely going down. And they always I recommend a middleman connector such as ferrules. I've tried putting just straight wires in. It doesn't work great in my practice. And I've also seen it damage ferrules, which I didn't think was possible. Avoiding connectors. This is what our team uses personally. We try our hardest to avoid using any actual connectors wherever we can. It's very simple. We're not worried about having a bunch of tooling and a bunch of extra parts. We still do carry around Andersons just in case because they are a great connector, but we try our best to avoid them wherever we can. And it's very consistent. It's always going to work, and you're never again worried about having to use a certain type of tool that you might not have. Soldering where we need it. If there's a connection that we have to make that we're not using a connector for, we try our best to solder it. It happens on our CAN bus a couple times. And the biggest downside to that is that this does require a lot of skill and trust in the students that you have doing these solder connections. Um, Obviously, you need to position those properly to make sure they're away from bends. And solder connections can be brittle eventually, which can cause that connection to break. Um, Additionally, I recommend soldering if you are using other connectors. I forgot to put this in. Soldering the actual metal connector on is a great idea. We started doing it recently after 2023, um, and it's proven great to us so far, especially on our Molex connectors. The really small ones, you dab a little bit of solder on, and it works great to hold it on just that little bit extra. Using bolt-on motor connectors is absolutely great. It extends your motor lifetimes. You're not ever worried about those built-in wires ever eventually getting too short. I'm always scared about it, even though we have a ton of length on most of ours, but scares me every time. And they are probably the strongest connectors when they're done properly. You have your ring terminal and then a bolt-in, and it's very difficult for that to come out. The big cons to this is it is very time-consuming to set up. And it requires a lot of precision in making sure that everything is done properly. Because if something has been done improperly and you're not using connectors, it takes a very, very long time to fix those problems. And you have to go through a lot of problem solving steps. That did unfortunately happen on our 2024 practice bot where we had to solder some things and they were soldered incorrectly. We had to go back and fix a lot of things on it. RJ45, the Ethernet connector. It's bad. I hate it with a passion. We've had a lot of issues with it. If any of you know what happened at DCMP, you know I also hate radios. It's all cons. We are forced to use this connector. We have no choice, and I wish we did. It's very weak. Okay, the lock on the connector is usually plastic. If you're really lucky and you have a very high cat cable, sometimes they're metal. I think that even the ones we use are still plastic, unfortunately. The connector itself is also very weak. The pins on it are very weak. They can pop out or you lose contact very easily. And the housings that they're built in are very weak and very susceptible to vibration damage. And if, FRC has a lot of vibrations in it, we tend to hit robots pretty hard. And our trailer does not have great suspension. So it bounces around quite a bit and has resulted in us using way too much hot glue. Also, high and low cat ratings. Honestly, for our applications, it rarely matters in terms of data transfer. But the best thing about high cat rating Ethernet cables is that they do have stronger connectors. They can be eventually made out of metal. And I do recommend those if you can get them, but they can be a little bit pricey. Next, the DuPont connector, which is the Molex one. Again, I hate this with a burning passion. I've had too many issues with this one personally, but we are forced to use it if we're using digital I/O on our robot with the Rio. They have no lock. There are some great 3D printed options available on Cheap Delphi. If any of you are looking for them, they do have locks on them. I can't say I can't express how great they are. And the connectors themselves are structurally weak. The lock that holds in the wires into the connector is barely there. And given the forces that FRC can apply to wires, they can get pulled out way too easily. And even in the Rio itself, we've had to hot glue our wires, like our connectors in sometimes. I also have heard of a team told me that their hot glue was conductive. So be careful of that. I don't know how that happened. Strain relief. It's bad. I'm very much kidding. It is great. Where to apply it everywhere you can, okay? Making sure that all of your devices have strain relief on them is honestly a necessity in my opinion. Again, you guys probably know about Archimedes 2023. This is the reason why we have it, and it's been great ever since. We have not had any of our wires pop out accidentally or in a match at all. You can see it on our radio here. We have our zip ties that hold it on, and then there's little plastic brackets with some zip ties that hold the wires in. They're amazing. It does a lot of things. It takes a lot of stress off of your wires, but also off the connectors, and especially on things like Ethernet and Molex. That strain relief really helps keep those connectors in because it's keeping forces away from it and putting it right into that strain relief. Obviously, like I said, it offers a lot of protection to your devices and your wires. Pneumatic applications. This year, the first year in ages we haven't used pneumatics, and I'm kind of sad about it. But back on 2024, again, those that know 2023 Archimedes, um, we had these little clips that we put onto our robot last year, which physically stopped the valves from ever loosening up over our tubing. Um, which is why that entire year we never had any issues with our pneumatics whatsoever. Um, again, like I said, the examples comparing 2023 and 2024 there. Next, we're moving on to batteries. Um, so firstly, I am talking about surface charge. I do want to preface this with this is all what I found in my own findings. I do know people have lots of opinions on this, so I do not want to get too in depth into that right now. But I can do that after the presentation. Like I said, this is what I've noticed. It usually looks like it wears off before use. I have measured batteries after taking them off the charger. Any significant decrease in voltage has gone away after about 10 minutes. Between 10 minutes and half an hour, I think I lost 20 millivolts for those that care. It dropped down 0.3 volts initially. Um, it doesn't look like that actually applies too much to what we are doing. The other factors that I think are pretty much playing a bigger role in what we think of as surface charge is temperature and trickle charges. Starting off with trickle chargers, when we leave them on, when we leave our batteries plugged in at night, what trickle chargers do is they charge above the voltage and then they bring it back down to exactly where they want the battery to sit at. Right now, after a whole night sat, it's just sitting at that one voltage and it's lost whatever it had. Now, when we get that in the mornings, it means that we have a little bit less voltage than we do during the day after just pulling it off a charger. The other thing there is temperature. Not only do the trickle chargers add temperature to the batteries, but the buildings are usually quite cooled at night because we're not there heating it up. Once we get there, it's been in the robot and charged, the temperature increases significantly. And if anyone's pulled out their phone in the winter, it helps a lot after you've warmed it up. The use cases for this is, like I've said, we actually had a lot of issues this season where the next morning our batteries would suck. After one cycle, though, they'd be great and they'd be working properly again. So that's why I kind of wanted to touch on that, was just that like temperature can play a part in how your batteries are working in your robots. What time am I at? Okay. Getting the most out of your batteries. This is really important, especially over a whole FRC season, which can take a lot of toll on your batteries, especially depending on how much practice you're doing. Cycling your batteries can be really important. Avoiding repeated use is almost necessary to make sure that all your batteries are about as good as each other. There are always going to be some few dud batteries and a few amazing batteries that you have. But trying to make sure that you're cycling through all of them equally helps reduce the wear on a single battery. Ideally, I recommend having 8 to 12 batteries. 4 is the minimum I'd say that you should have. But 8 to 12 is a good number to allow you to cycle those batteries properly and avoid that repeated use that does damage your batteries quite quickly. And using trickle chargers, I don't know if many teams don't use trickle chargers because they're the most available ones, but it really does help improve your battery life. It takes a lot of stress off of your batteries going way above the voltage that they're supposed to be at constantly can really hurt them and degrade them by the end of the season, especially where it matters most when you're getting to your like second event, DCMP, where you get to there. And lastly, keeping your batteries safe. Making sure that you're securing your Anderson is one of the most important things to keeping your on-field performance solid and there. Using either zip ties or Velcro. I actually have some over here. I forgot about this. I had so much stuff over here. Firstly, this is a zip tie gun for any of you that haven't seen this before. It's really cool. You just stick it on your zip ties, you squeeze it, it tightens your zip ties, and then cuts off the end. You never have to use snips when you're using your batteries, so your zip ties. It's great. I recommend it. Just be careful with using this on wires, especially Ethernet or any other small wires. It can damage them, so just be careful with that. We have these cool Velcro straps. We use these on previous robots. But they're a little strap and they feed through. These are great for holding your Anderson on as well. Again, like I said, we used these back in 2023. And then the last 2 years we've been using just straight zip ties. It is a lot of zip ties and a lot of waste. I don't like that part, but they are more secure than this Velcro is. On to my next point. I've highlighted this in red for a very specific reason. Secure your batteries. Making sure that you have mounts or holders for your batteries is very important. Losing your battery mid-match will get you e-stops, and that's not fun for anybody. It's not fun for your drive team, not fun for the people watching. It does hurt a lot. Using mounts and holders is almost a necessity. We have it's hard to demonstrate here, but we have a whole clip that goes around our battery every time we put it in. That is great for making sure that that battery just cannot come out. It's also buried in the robot just to make sure that no matter what happens, it's in there. Um, Obviously, this can get you e-stopped, but additionally, batteries getting hit on field can cause acid leaks, and that's again that can that can ruin an event if that gets on the carpet. So trying to make sure that you keep your battery secure is by far the most important thing you do with your electrical system. And keeping your I said batteries covered, but everything covered again. It helps keep dust and debris out of the place where your battery sits, making sure it's in there nice and securely. Keeps it out of your Anderson. That can cause not only it to not connect properly, but it puts a lot of additional wear onto that battery Anderson, where that dust and dirt grinds down that metal a lot more than people think it does, and can damage it to the point where that connector becomes so loose it just pops out. And trying to keep your batteries away from moving parts. Like I said before, your battery is very not delicate, but important and can be damaged. And especially if something happens, like an acid leak in your robot, that is not good. Very hard to do, but don't try. Um, so keeping everything covered, keeping everything away from your batteries is very important. That's it for what I had. Does anyone have any final questions? Just before I answer your question, I will. If we are done with electrical questions, I will have a robot Q&A going out afterwards. It's a mini one. There will be more happening at lunch. So electrical questions about the presentation first. Yes. Yes. Not to my knowledge, but I wouldn't want to see one leak. So that's the only reason I say that is just as much as we haven't, the possibility of it is still there, and mitigating that as much as we can is obviously important. Yep.
How often do you guys typically swap out your batteries? Like, do they last you 2 seasons on average, or do you swap it every season?
So our team goes every season. With our batteries, we have way too many of them stockpiled up. We do also use them for other projects. So the class projects use some of the batteries. We have a solar panel project going on that's using like 6 of them. So we do try our best to recycle the batteries where we can. Anyone else have any questions about the presentation? Anything? I can go back to slides. Yep.
For your Krakens,
Yeah.
you keep them with the 10 gauge line, because I think once we ended up connecting the Krakens to a 12 gauge wire. Do
Yes.
you think is that
It. So on our drive motors this year did actually use we did stick with 10 gauge wire. We didn't do that last year. We did 12 gauge last year. We only did it for our drive motors. Everything else is on 12 gauge. For our Krakens. But I don't know the actual numbers on how much resistance you lose. I don't think it's a ton, but it is an option that you have. It might give you a little bit more power, but I don't think it's a significant amount.
Yeah. I'm not sure Krakens, but the Kraken leads, are they built-in 10?
So there's actually no built-in leads on the Krakens here. I've got both here. So there's screw terminals, if you guys can see them there. And you can attach whatever gauge wire you want. They do come with wires with screw terminals on them. Those are 10 gauge. But you can put whatever you want on with the screw terminals. That's what they look like without the wires. And then you have some nice bolt. They do come with Torx Plus bolts. I forgot to mention that. It is pretty expensive to get one of those screwdrivers. We swapped all of ours out for Torx because we have way more Torx and it's just easier to use.
West Coast Institute make a torque wrench for that bit, specifically for the Canon power terminal that is preset.
Yeah.
To do anything that's the right torque spec.
Any other questions? Yep.
You said the bolt connectors are not that good. Would you recommend making something with that before?
I would recommend a custom adapter if you're using DIO. That or a bunch of hot glue. It does work well. Again, unless you have a certain team's conductive hot glue, that it is absolutely the hot glue holds it in perfectly. You just do have to be careful about getting hot glue into your other pins in there and making sure you can get that out easily. Yeah, unfortunately, there isn't really many other replacements for it. I wish there were. Any other questions? Yep.
How do you plan energy chains and wiring on moving parts?
Moving parts. Well, we try to keep obviously everything secured to whatever part it's going to be on. We figure out where every wire has to go somewhere, right? So, for example, this here, well, this is way higher than it used to be. Obviously, the entire elevator here has a bunch of wires on it. And so what we try to do is keep all the wires going up in one spot and find the most convenient place to do that. This year, that happened to be right here, where we sent everything up to the top of our elevator and then back down. It just keeps the cable chain out of the way. How we design that is just where it's easiest for us to fit in, and there's nothing in front of the elevator here. So it just made our lives a little bit easier.
To secure the cable chain, you would use like 3D parts.
Yes, we do use a 3D. No, we don't. I can't even remember. That is printed. Yes, we do use a 3D printed part to secure it. But it's been really strong, and we print with knockoff onyx for that. Any other questions for this? If you guys want to come up, you can come ask questions. I have a bunch of answers. If Ballers wants to say anything, he also has a bunch of answers there. So that's it for that presentation. Thank you so much for coming. I know. Yo, this is such a great